technological unemployment is unemployment primarily caused by technological change. Early concern about technological unemployment was exemplified by the Luddites, textile workers who feared that automated looms would allow more productivity with fewer workers, leading to mass unemployment. But while automation did lead to textile workers being laid off, new jobs in other industries developed. Due to this shift of labor from automated industries to non-automated industries, technological unemployment has been called the Luddite Fallacy. Modern proponents of technological unemployment argue that productivity has been decoupling from employment throughout the 21st century, as increasing numbers of industries are automating simultaneously. They point to studies showing that the job losses are most concentrated in occupations involving routine physical and mental labor, the jobs that are easiest to automate. In 2014, Pew Research canvassed 1,896 technology professionals and economists and found a split of opinion. 48% of respondents believed that new technologies would displace more jobs than they would create by the year 2025, while 52% maintained that they would not. Views. John Maynard Keynes used the term as early as 1930, warning, "We are being afflicted with a new disease of which some readers may not yet have heard the name, but of which they will hear a great deal in the years to come, namely, technological unemployment. This means unemployment due to our discovery of means of economizing the use of labor outrunning the pace at which we can find new uses for labor. But this is only a temporary phase of maladjustment." Economist Alex Tabarrok's summary of the concept states that, if the Luddite fallacy were true, we would all be out of work because productivity has been increasing for 2 centuries. Former U.S. Treasury Secretary and Harvard economics professor Lawrence Summers argues that this time will be different. Here are many reasons to think the software revolution will be even more profound than the agricultural revolution. This time around, change will come faster and affect a much larger share of the economy. Here are more sectors losing jobs than creating jobs. And the general-purpose aspect of software technology means that even the industries and jobs that it creates are not forever. If current trends continue, it could well be that a generation from now a quarter of middle-aged men will be out of work at any given moment. Labor-displacing technologies can generally be classified under the headings of mechanization, automation, and process improvement. The first 2 fundamentally involve transferring tasks from humans to machines. The third fundamentally involves the elimination of tasks altogether. The common theme of all 3 is that tasks are removed from the workforce, decreasing employment. In practice, the categories often overlap. A process improvement can include an automating or mechanizing achievement. The line between mechanization and automation is also subjective, as sometimes mechanization can involve sufficient control to be viewed as part of automation. Unemployment due to an increment in productivity generates an expectancy that no new jobs, or not enough new jobs, will arise to fill the void. Variants of this argument persist through the present day, as do counter-arguments to it. Average working hours have decreased significantly since the advent of modern efficiency-producing technologies and continue to fall as less and less labor is needed to meet demand. The notion of technological unemployment leading to structural unemployment is labeled the Luddite fallacy. If a firm's technological innovation results in a reduction of labor inputs, then the firm's cost of production falls, which shifts the firm's supply curve outward and reduces the price of the good. The widespread adoption of the innovator's technology could lead to market entry by new firms, partially offsetting the displaced labor, but the main benefit to the innovation is the increase in aggregate demand that results from the price decrease. As long as real prices fall, the additional purchasing power gives consumers the ability to purchase more products and services. With technological innovation, these are often products and services new to the consumer, such as better healthcare or wireless communication devices and services. This increase in aggregate demand leads many economists to believe that technological change, although disruptive of individual careers and particular firms, cannot lead to systemic unemployment, but actually increases employment due to its expansionary effect on the economy. The economist bases this belief on 2 assumptions: that machines are used as tools to increase workers' production, and that most workers will be able to operate those machines, and argues that the increase in computerized automation can destroy works in a disruptive way, with the new jobs being out of reach of the capabilities of most workers. Different views have been expressed on the rate of technological progress, with many, such as C.O. and Paep, Tyler Cowen, Robert W. Ayres claiming that it is decelerating and others saying technological change is accelerating. Other economists contend that the rate of technological change has become so rapid in the area of information and communication technologies that the adverse latent effects of productivity on employment may outpace job growth in an economy increasingly reliant on the development of these tertiary and quaternary economic sectors. The technological acceleration argument is counter to the fact that productivity in developed countries has been slowing down for decades. This has been explained in part by the claim that the remainder of labor and energy to be saved in important economic processes is trivial compared to what has already been saved. Examples are agriculture, where 98% of the labor has been removed, and electrical generation, which is approaching thermodynamic limits. Researchers from the University of Chicago have documented a worldwide downwards trend in the share of labor income in the last 3 decades, in the form of lower wages and benefits with increased inequality across industries, and a rising share going to capital income, beyond what can be explained by recession, and attributed to structural changes in technology, market structures and labor unions. In principle, technological unemployment may be distinguished from unemployment caused merely by the contraction phases of business cycles. In practice, such differentiation is difficult, owing to the multivariate nature of economics. Like unemployment in general, most technological unemployment is temporary, as unemployed workers eventually find new jobs. For several centuries, the main controversy about technological unemployment has been whether it can ever lead to structural unemployment. History: early in the Industrial Revolution. Historical concerns about the effects of automation date back to the very beginning of the Industrial Revolution, when a social movement of English textile machine operators in the early 19th century known as the Luddites protested against Jacquard's automated weaving looms. The Luddites destroyed a number of these machines, which they felt threatened their jobs. The original Luddites were hosiery and lace workers in Nottingham, England in 1811. They smashed knitting machines that embodied new labor-saving technology as a protest against unemployment, publicizing their actions in circulars mysteriously signed, King Lud. The Luddite events of 1811 were the beginning of humankind's analysis of whether it is possible for technological unemployment to be other than temporary and confined to particular industries and firms. Contrary to the Luddites' fears, technological advancement did not ruin Britain's economy or systemically lower standards of living throughout the following decades of the 19th century. In fact, during the 19th and 20th centuries, the opposite happened, as technology helped Britain to become much less impoverished than before. For this reason, some economists think that the general Luddite premise is fundamentally flawed, and thus they apply the term Luddite fallacy to it. Economist Alex Tabarrok summarizes the fallacy as: if the Luddite fallacy were true, we would all be out of work because productivity has been increasing for 2 centuries. Ronnie Bray writes, the Luddite fallacy referred to here fallaciously misdirects the reader's attention away from the major objection and opposition raised by Luddites to the introduction of machines in textile and related industries. All available Luddite literature, usually in the form of popular songs, protest songs, and broadsheets, shows that unemployment, poverty, and starvation were their major concerns. Thus, it is wrong to label them as anti-technology because they were anti-starvation. The difference is not wasted on those that have endured starvation. It is right to say that for the most part they saw power looms, cropping frames, and mechanical knitting frames, as the direct cause of unemployment, which condition led to cessation of income, which led directly to starvation in short time. It cannot be doubted that had mechanization either maintained or increased the level of employment in the affected industries, that there would have been no uprising on account of mechanization. Professor Kevin Binfield of Murray State University seems to agree that the Luddites were not universal technophobes. He claims the machines suppressed workers' wages at a time when the Luddites, who were artisans and skilled workers relying on their wages to buy food, especially feared famine due to rising food prices. This made the machines the most accessible target for the Luddites' angry expression of that fear. During the machine age, as in the preceding century, the period from the 1880s to the late 1920s saw no underlying automation-induced structural lack of new economic opportunities for skilled workers given enough time for searching. The Great Depression then caused a tremendous disruption in employment. But the foundational potential for full employment had not been lost, as would later be shown by the post-Euro World War II economic expansion and other economic miracles. In the 1930s, John Maynard Keynes predicted that a century later there would be a 15-hour work week, as the economic problem would be replaced by the problem of leisure. 1950s to present. The 1950s and 60s were optimistic economic times in many respects, and during this era many optimists made forecasts similar to Keynes's 1930s discussion of a pending abundance of leisure time. Meanwhile, pessimists questioned the role of labor in such a world and how people would earn a living or occupy their time. During the 1960s, economic growth did lead to a rise in real income per capita and a decline in the average number of work hours per week. Yet, real income and the length of the work week have remained relatively constant in the United States since then, even after the influx of a large number of women into the workforce. Despite the elimination of manual labor and assembly line jobs after World War II via advancing mechanization and automation, employment in the services sector absorbed the displaced labor from the industrial sector. For example, many manufacturing jobs left the United States during the 1990s but were offset by a one-time massive increase in information technology jobs at the same time. In some cases, freeing up of the labor force allows more people to enter higher-skilled managerial jobs and technologically specialized jobs, which are typically higher-paying. Works by scholars David F. Noble and Jeremy Rifkin are dedicated to study the social history of automation and the potential impact of scientific and technological changes on the economy. They are sometimes mocked with the disparaging label neo-Luddite. Post-market theories, Rifkin's The End of Work, published in 1995, predicted that automation-induced unemployment would begin to be widespread within the following decade due to the sudden and massive development of informational technology. The book focuses mostly on robotics, mentioning the Internet once in passing and the World Wide Web not at all. It calls the new era the post-market economy, although it does not offer details on what should replace the market. Political philosopher George Cafancy identified Rifkin as major participant in the end-of-work discourse of the 1990s, and discounted his argument as not taking into account the dynamics of employment and technological change in the capitalist era. Market-based ideas, James S. Albus, a United States government engineer and pioneering inventor in automation, robotics and other intelligent systems, was concerned for many years about the potential social impact of advanced intelligent systems. Dr. Albus was optimistic about the wealth-producing capabilities of intelligent machines but concerned about the elimination of jobs and downward pressure advanced automation placed on human wages and incomes. In his 1976 book titled People's Capitalism, The Economics of the Robot Revolution, and on his websites, Albus lays out a plan to broaden capital ownership to the point where every citizen becomes a capitalist with a substantial income from personal ownership of capital assets. This would achieve an economic system where income from ownership of capital assets would supplement a euro, and eventually supplant a euro wages and salaries as the primary source of income for the average citizen. Albus believes this would lead to a world of prosperity and opportunity without poverty, war or pollution. Marshall Brain and Martin Ford, author of the 2009 book The Lights in the Tunnel, Automation, Accelerating Technology and the Economy of the Future, are IT engineers who worry that advancing IT will displace workers faster than current economic structures can absorb them back into the economy. Ford presents an argument for why the Luddite premise, although fallacious for 2 centuries, might nevertheless become valid as the speed of development of new machine technology differs substantially from the past. He compares this to the standard warning in financial prospectuses that past performance is not a guarantee of future results. Brain and Ford both advocate pursuing some permutation of basic income or guaranteed minimum income, simply to keep the recirculation of value throughout the economy from stalling due to low employment. Although the earliest variants of these ideas involve direct support from the government, which could tax highly automated companies and use the revenue for both basic income and select re-employment, they have also evolved to include market-based mechanisms, comparable to minimum wage laws, requiring the private sector to employ humans but leaving the job descriptions to private innovation. In these lines of thinking, it is recognized that automation can continue to yield ever higher per capita standards of living, but the basic income or new markets decouple consumer purchasing power and confidence from the traditional labor market, which can suffer from fluctuations in the business cycle or even potential market failure. In its place would grow a new labor market insulated from these concerns. In their books The Second Machine Age, Work, Progress, and Prosperity in a Time of Brilliant Technologies and Race Against the Machine, How the Digital Revolution is Accelerating Innovation, Driving Productivity, and Irreversibly Transforming Employment and the Economy, MIT professors Andrew McAfee and Eric Brynjolfsson write that the pace of automation has picked up in recent years due to a combination of increasingly clever advanced digital technologies. They write these technologies are making people more innovative, productive and financially richer, both in the short and long term, but at the cost of increasing wealth inequality in society. In the author's view, one of the main inegalitarian consequences of digital technological developments is its potentially negative impact on well-paid employment. The authors recommend governments consider modifying public education systems to place greater emphasis on teaching creativity and entrepreneurship, increasing investments in infrastructure and basic research, and revising tax policies to reward employers for hiring people and to increase the tax rates on wealthy individuals. The authors advocate for a collaborative partnership between computers and humans as the road to future job creation. In medicine, law, finance, retailing, manufacturing and even scientific discovery, they write, the key to winning the race is not to compete against machines but to compete with machines. Larry Summers wrote about the devastating consequences of robots, 3D printing, artificial intelligence, and similar technologies for those who perform routine tasks. In his view, already there are more American men on disability insurance than doing production work in manufacturing. And the trends are all in the wrong direction, particularly for the less skilled, as the capacity of capital embodying artificial intelligence to replace white-collar as well as blue-collar work will increase rapidly in the years ahead. Summers recommends more vigorous cooperative efforts to address the myriad devices enabling the holders of great wealth to avoid paying income and estate taxes, and to make it more difficult to accumulate great fortunes without requiring great social contributions in return, including more vigorous enforcement of anti-monopoly laws, reductions in excessive protection for intellectual property, greater encouragement of profit-sharing schemes that may benefit workers and give them a stake in wealth accumulation, strengthening of collective bargaining arrangements, improvements in corporate governance, strengthening of financial regulation to eliminate subsidies to financial activity, easing of land use restrictions that may cause the real estate of the rich to keep rising in value, better training for young people and retraining for displaced workers, and increased public and private investment in infrastructure development, for example in energy production and transportation. Michael Spence wrote that now comes a powerful wave of digital technology that is replacing labor in increasingly complex tasks. This process of labor substitution and disintermediation has been underway for some time in service sectors. Think of ATMs, online banking, enterprise resource planning, customer relationship management, mobile payment systems, and much more. This revolution is spreading to the production of goods, where robots and 3D printing are displacing labor. In his view, the vast majority of the cost of digital technologies comes at the start, in the design of hardware and, more important, in creating the software that enables machines to carry out various tasks. Once this is achieved, the marginal cost of the hardware is relatively low, and the marginal cost of replicating the software is essentially zero. with a huge potential global market to amortize the upfront fixed costs of design and testing. The incentives to invest in digital technologies are compelling. Spence believes that, unlike prior digital technologies, which drove firms to deploy underutilized pools of valuable labor around the world, the motivating force in the current wave of digital technologies is cost reduction via the replacement of labor. For example, as the cost of 3D printing technology declines, it is easy to imagine that production may become extremely local and customized. Moreover, production may occur in response to actual demand, not anticipated or forecast demand. Meanwhile, the impact of robotics is not confined to production. Though self-driving cars and drones are the most attention-getting examples, the impact on logistics is no less transformative. Computers and robotic cranes that schedule and move containers around and load ships now control the port of Singapore, one of the most efficient in the world. Spence believes that labor, no matter how inexpensive, will become a less important asset for growth and employment expansion, with labor-intensive, process-oriented manufacturing becoming less effective, and that relocalization will appear globally. In his view, production will not disappear, but it will be less labor-intensive, and all countries will eventually need to rebuild their growth models around digital technologies and the human capital supporting their deployment and expansion. Spence writes that the world we are entering is one in which the most powerful global flows will be ideas and digital capital, not goods, services, and traditional capital. Adapting to this will require shifts in mindsets, policies, investments, and quite possibly models of employment and distribution. Ryan Avent, an economics correspondent for The Economist, reports that one possible solution may be to restore some of the labor market regulations that protected workers in previous decades. However, in Avent's view, this could increase the cost of labor, which could increase firms' interest in substituting labor-saving technologies for workers, potentially cancelling out the beneficial effects. Another option may be to improve workers' education. And a third option may be a form of redistribution, by giving workers a share of ownership in the corporation, or by increasing taxes on the owners of capital and distributing the funds to workers. Non-market-based ideas. Albert Einstein wrote that technological progress frequently results in more unemployment rather than in an easing of the burden of work for all. He proposed the establishment of a socialist economy, together with an educational system focused on social goals. See also. References. Bibliography. Further reading, Rampton, Ramin, Capitalism and Automation, Revolution in Technology and Capitalist Breakdown, London, UK and Concord, Massachusetts, US, Pluto Press, ISBN A978-0-7453-0370-3. Scott, Ellis L. Boltz, Roger W. University of Georgia. Reliance Electric Company, Automation and Society, Athens, Georgia, US, Center for the Study of Automation and Society, Ayres, Robert U. Turning Point, An End to the Growth Paradigm. London, Earthscan Publications. External links, Larry Page, Sergey Brin and Vinod Khosla discuss their views on the socio-economic effects of advanced intelligent systems and how advanced digital technologies can be used to create abundance, provide for people's needs, shorten the workweek, and mitigate any potential detrimental effects of technological unemployment. July 3, 2014. Starting at about 13:00 into the video. The audience is composed of the CEOs of the portfolio companies of Khosla Ventures. Now machines are taking middle-class jobs. Business Spectator, could robots replace nearly half of us in the workforce? Australian Broadcasting Corporation, what jobs will the robots take? The Atlantic, welcome, robot overlords. Please don't fire us. Mother Jones, the uncertainty of our high-tech future, are computers taking our jobs? Scientific American and Salon, on caregiver robots and jobs, Zeynep Tawfiqchi, UNCI School, are our jobs doomed? Report shows the potentially devastating effects of robots on the job market. Salon, how human-robot teamwork will upend manufacturing, MIT Technology Review.